All right, so today we'll be looking at exponential equations. So we have three equations, and the first two you solve in a very similar manner. The third one is a bit different in terms of technique that we use. So let me get started with A. We'll go ahead and work on A and B, and on this video, and then C, we'll go ahead and do another video on that. All right. So with A, you have 2 to the 4x plus 5 equals 1 over 32. All right, so the first thing you want to do when you're solving an exponential equation is that you want to make sure the part that has the exponent, the 2 to the 4x plus 5, is isolated. It's by itself, which it is in this case. Yeah, if I had like a 1 added on here, then I'd subtract the 1 over. Okay. Now once we've done that, what you want to make sure is that the other side of the equation is, if it's just a number, then it's just positive, okay? The reason for that is an exponential never equals a negative, okay? You can't have 2 to the something, or any number to the something equals something negative. You know, we don't allow that here, okay? So we're going to go ahead and go to the next step, which is this. Once you've got all those things checked out, you're going to try to write both sides with the same base, okay? So what is this base in this case? I would say it's base 2. 1 over 32 is like saying, 32 itself is like saying 2 to the 5th. So 1 over 32 is like saying 1 over 2 to the 5th. And 1 over 2 to the 5th, another way of writing that is 2 to the minus 5th by properties of exponents. So both sides are now written in the same base 2. Okay, so and if you can do that with any equation, with exponential, you can certainly do that. And the next step is such. You're going to go ahead and set the exponents equal to each other. We're using a property about exponential functions which have this property which they're one-to-one. And essentially what that means in our case is we have an equation with two bases that are the same, then the powers have to be the same. Okay, so the 4x plus 5 and the minus 5 have to equal each other. Okay, some people kind of think of it as, oh, like the 2's cancel. Yeah, not really. We can sometimes it's like an ad hoc way of remembering that, but just be careful. All right. And essentially what you do at this point is you solve for x. So you go ahead and subtract 5 from both sides and divide by 4. And minus 5 halves would be your answer. So just going over these steps again. 1, you want to make sure that your exponentials are by themselves. There's nothing attached. If you do have something attached, you move it to the other side. And then what you try to do after that is you try to write things with the same base. In this case, it's base 2. And you go ahead and then set the exponents equal, the powers equal to each other at this point, and then you solve for x. All right, so let's try that out with the next question. 1 over 25 to the 3 halves x minus 1 equals 125 to the third. So I'm going to go ahead and copy this and paste. And yeah, so the first thing is just to make sure, yeah, nothing attached to the exponents. And the next thing is, yeah, I have a positive on the other side. So from here, we're going to try to write both these expressions with the same base. So 125 to the third power and 1 over 25 all to the 3 halves x minus 1. 25 and 125 can be written in terms of base 5. 1 over 5 squared is what 1 over 25 is. 5 to the third is what 125 is. So this part would be written, the 125 to the third now in base 5 would be 5 to the third and then to the third power because of that 3 on the exponent here. We have there. All right. However, I need to write this with the same base 5. So I need to bring up that 5 to the second. Oh, that's on the denominator. Rewrite it as 5 to the minus 2. And what we're going to do next is as follows. We're going to use properties of exponents. Properties of exponents say that if you have an exponent, which you raise to a power, so a to the b, and then you raise it to c, it's equal to ab times c. So you multiply the powers together. So in our case, 5 to the third would be 5 to the ninth, 3 times 3. And then 5 to the minus 2 raised to the 3 halves x minus 1. What we're going to do is we're going to distribute the negative 2. And this would become minus 3x plus 2. Okay. So again, you distribute there and boom. And again, we'll set the powers equal to each other because the bases are the same. And we'll solve. 7 here, 9 minus 2 is 7, and x equals minus 7/3. And that is our answer. Okay. It is possible that you can have exponential equations where you have x's on both sides. So 4 to 3x minus 1 equals, let's say, 2 to the 7x plus 4, something like that. That's perfectly legit. And the same steps would hold in the sense of like writing these in the same base and then setting the powers equal to each other. So all of that would still hold, but I just wanted to let you know that can occur. All right, well, thank you for your time.